Hello everyone, welcome back to Biochemistry Pearls. In this video, we will decode metabolic alkalosis, its causes, underlying pathophysiology, and how body tries to restore the balance. So as we all know, what is metabolic alkalosis? The primary defect is bicarbonate excess. So here also we are discussing the whole topic with one particular equation, Henderson-Hasselbalch's equation. pH equals 6.1 plus log HCO3 by H2CO3. So since we are discussing about alkalosis, pH is increased. So what change you are expecting in HCO3 to increase the pH? HCO3 has also to increase. So here the ratio will be more than 20:1. Moving on to the causes. The primary causes of alkalosis occurs when excess base is added in our body. Then, when base excretion is defective in our body. The third one is whenever acid is lost from our body. So, moving on to the causes in detail. So, the first one is loss of HCl and chloride ions, especially seen in vomiting in pyloric stenosis, gastric lavage. So these are the causes of hypochloremic alkalosis. Now, moving on to the second cause, that is diuretic therapy. So when we are using loop diuretics, it blocks the reabsorption of sodium, potassium and chloride ions. Moving on to the third cause, Cushing syndrome and primary aldosteronism. Increased levels of mineralocorticoids causes increased net acid excretion. Now, the fourth cause is severe potassium deficiency. When we discuss about metabolic acidosis, that time we taught it is associated with hyperkalemia and the explanation is already given. So here metabolic alkalosis is associated with hypokalemia. Fifth cause, excess alkali intake. The causes are massive blood transfusion and IV therapy with bicarbonate solution and use of antacids in treatment of peptic ulcers and gastritis. So these are the major causes of metabolic alkalosis. Moving on to the compensatory mechanisms, when we discuss about acid-base disorder in the first video, I told you whenever there is metabolic disorder, it is compensated by lungs. So here, the lungs will hypoventilate because of depression of respiratory centers, increase pH, it will cause an increase in PCO2. Now, we will be explaining the types of metabolic alkalosis based upon the compensatory mechanisms. So here, before starting the types of metabolic alkalosis, the primary defect is pH is increased and HCO3 values are also increased. Now, with Henderson-Hasselbalch's equation, pH is proportional to HCO3 by H2CO3. So what happens? pH is increased, HCO3 is also increased. That means it is metabolic alkalosis. And if PCO2 remains within normal reference range, that means there is no compensation that is happening in our body, that is uncompensated metabolic alkalosis. Moving to the second type, here also we are writing the same equation, pH proportional to HCO3 by H2CO3. So here pH is increased, HCO3 is also increased. So what change you are expecting in PCO2 to bring down the pH value? PCO2 should increase. So this type of metabolic alkalosis is known as partially compensated metabolic alkalosis. Now moving to the third type, that is pH is again proportional to HCO3 by PCO2. pH will be increased in metabolic alkalosis if PCO2 is further increased and bringing back the pH to normal value. That type of metabolic alkalosis is known as fully compensated metabolic alkalosis. So these are the three types of metabolic alkalosis. In this particular fully compensated type, the ratio will be 20:1. The ratio is maintained. Now moving on to the calculation of compensation in metabolic alkalosis. So we are following a formula for the calculation, that is expected PCO2 equals 0.9 into HCO3 plus 16 plus or minus 2. So this is the expected PCO2 calculation in metabolic alkalosis. Now we will discuss some ABG data. The first ABG data, it is pH is 7.50, HCO3 is 35 and PCO2 is 45. So first we have to know the normal reference range. pH it is 7.38 to 7.42, HCO3 22 to 26, PCO2 35 to 45 mmHg. So from this data, pH is increased, that means it is alkalosis. And HCO3 is also increased, it is metabolic. And here the PCO2 remains normal, that means it is uncompensated metabolic alkalosis. I'm sorry for the spelling mistake I have written there. Moving on to the second data. It's a case scenario of 28-year-old man who was admitted to the hospital with a history of severe vomiting. He was clinically severely dehydrated and shallow respiration, and the biochemical results are shown as pH equals 7.52, PCO2 is 40, HCO3 is 43 millimole per liter. So here also the pH is increased. That means it is alkalosis. HCO3 is also increased. It is metabolic alkalosis. Since there is normal PCO2 value, it is uncompensated metabolic alkalosis. So I hope the concept is clear. Thank you.
Free audio post-production by alphonic.com.